Hi everyone. In this class, we are going to discuss about electric dipole. What is electric dipole? So determine electric potential due to the dipole and determine electric field intensity due to electric dipole. So first of all, what is the definition of electric dipole? Two point charges of equal magnitude but opposite sign are separated by very small distance d. 2 point charges of equal magnitude but opposite signs are separated by very small distance t is called as electric dipole. Now here in this figure there are 2 point charges, and this is point charge plus q coulombs and this is point charge minus q coulombs, and this is point A and this is point A and this is point B. So 2 point charges of equal magnitude. Magnitude is same but opposite side. One is the positive charge and second one is negative charge, but opposite side. Those 2 point charges are separated by very small distance. What is the distance between these 2 point charges? Small d, which is called as electric dipole. Electric dipole. The field produced by such a dipole plays an important role in engineering electromagnetics. The electric field produced by such a dipole plays very important role in the study of engineering electromagnetics. So consider an electric dipole as shown in figure. 2 point charges plus q coulombs and minus q coulombs are separated by a small distance d meters, and R1. Consider a point P. That point P is P of r comma theta comma phi in spherical coordinate system. So now here consider point P, P of r comma theta comma phi in spherical coordinate system. In spherical coordinate system. At that point P, it is required to determine electric field intensity and electric potential. At that point P, determine electric field intensity and electric flux. Electric potential. So from in this figure, R1 is the distance from point R1 is the distance of point P from point A. R2 is the distance of point P from point B. Small r is the distance of point P from origin. So this point charge is point A and this point charge is point B. And this is the origin. R1 is the small r1 is the distance of point B from point charge plus Q or point A. R2 is the distance of point P from point B or negative charge. Smaller is the distance of point P from origin. On the z-axis, so what is that 2 point charges are placed on the z-axis. One point charge is placed on the positive z-axis and another point charge is placed on the negative z-axis. So what is the distance between 2 point charges? D meters with center as origin. So 0 to first point charge, point A, the distance is d by 2, and 0 to point B, the distance is minus d by 2. So on the positive z-axis at point A or positive point charge, what is the coordinate point? 0, 0, d by 2. At point B or negative charge, what is the coordinate point? 0, 0, minus d by 2. Okay, at the point P, we can determine electric potential due to the electric dipole. Then using E bar is equal to minus del V. So E bar is equal to minus del V is the relationship between electric field intensity, electric potential, and substitute electric potential equation in this relation. We get electric field intensity at point P due to the dipole. So this is the concept of electric dipole. What is a dipole? Next, coming to electric field intensity due to electric dipole. Determine electric field intensity at point P due to electric dipole. In spherical coordinate system, the potential at point P due to the dipole, at point P due to the charge Q. The electric potential expression already calculated, already explained in previous classes. What is the electric potential at point P due to the point charge Q is located at the origin? V is equal Q by 4 pi epsilon R. So using that concept, now here there are 2 point charges. Consider the point P in spherical coordinate system. At that point P, the potential at point P due to the charge plus Q is given by V1 is equal Q by 4 pi epsilon naught R1. Similarly, the potential at point P due to minus charge Q is given by V2 is equal minus Q by 4 pi epsilon naught R2, where R1 is the distance of point P from point charge plus Q, R2 is the distance of point P from negative charge. Therefore, the total potential at point P is the algebraic sum of V1 and V2. The total potential at point P is the algebraic sum of V1 and V2. So therefore, V is equal V1 plus V2. Substitute V1 and V2 values in this equation. We get the potential. The potential V is equal Q by 4 pi epsilon naught R1 minus Q by 4 pi epsilon naught R2. Both the terms Q by 4 pi epsilon is common into 1 by R1 minus 1 by R2. So take the LCM, that is equal Q is equal 4 pi epsilon naught into R2 minus R1 by R1 R2. So this is the electric potential at point P due to electric dipole. Electric potential at point P due to electric dipole. So now consider the point P is located far away from the electric dipole. So this is the electric dipole. This is the electric dipole, and this is point P. Now consider the point P is far away from the electric dipole. If that point P is considered far away from the electric dipole, the distance R1 and R2 and R approximately equal. R1 is approximately equal to R2 is approximately equal to R. That are parallel to each other. All the distance R1, R2 and R can be assumed to be parallel to each other. So from this figure, PA is equal, this is point A plus Q, positive charge is point A and negative charge is P. And PA is equal to R1 and PO is equal R, PB is equal R2. So draw the perpendicular line from point A on PB. Draw the perpendicular line from point A on PB. So from this figure, PB is equal BM plus MP. PB is equal, this is the point P, PB is equal PM plus BM. So AM is drawn perpendicular from point A on R2. The angle made by R1, R2 and R with Z-axis is theta, as all are parallel. So from the figure, cos theta is equal, and this is the angle theta. From this figure, cos theta is equal BM by AB. Cos theta is equal BM by AB. So BM is equal AB cos theta. What is AB? Distance between dipoles. That is small d. BM is equal d cos theta. So from the figure, PB is equal BM plus PM. What is BM? D cos theta. D cos theta. So PM is equal PA is equal PM. PA is equal R1. So PA is equal to R1, PB is equal to R2. As PA is equal to PA is equal to PM, as AM is drawn perpendicular. So therefore, PB is equal to BM plus PM. Therefore, R2 is equal. What is PB? PB is R2. BM is d cos theta plus PM. PM is equal PA. What is PA? R1. Therefore, R2 is equal d cos theta plus R1. So R1 is coming to the LHS side. We have R2 minus R1 is equal d cos theta. As d is very small, as the d is very small, the distance are equal. R1 is equal, R2 is equal R. R1 into R square. So what is the equation of the electric potential at point P due to the dipole? Q by 4 pi epsilon naught into R2 minus R1 by R1 R2. So what is R2 minus R1 here? D cos theta. As D is very small, R1 into R2 is R square. Substitute all the values into potential at point P due to the dipole expression. We get the potential V is equal QD by 4 pi epsilon naught R square. QD by 4 pi epsilon naught R square. Now here the potential is inversely proportional to square of the distance. Electric potential is inversely proportional to square of the distance. So now calculate electric field intensity. So we know that the relationship between electric potential and electric field intensity is E bar is equal minus del V. In spherical coordinate system, del V is dou V by dou R A R bar plus 1 by R dou V by dou theta A theta bar plus 1 by R sin theta dou V by dou pi A pi bar. So what is the potential V? V is equal QD cos theta by 4 pi epsilon naught R square. So differentiating potential V with respect to R, with respect to theta and with respect to pi, calculate dou V by dou R, dou V by dou theta and dou V by dou pi values. So calculate the potential V with respect to R, the resultant value is minus 2 QD cos theta by 4 pi epsilon naught R cube. And calculating differentiating potential V with respect to theta, the resultant value is minus QD sin theta by 4 pi epsilon naught R square. So differentiating potential V with respect to pi, dou V by dou pi is 0. Substitute dou V by dou R, dou V by dou theta, dou V by dou pi values into this equation, we get electric field intensity E bar is equal QD by 4 pi epsilon naught R cube into 2 cos theta AR bar plus sin theta A theta bar. So this is the equation of the electric field intensity at point P due to the dipole. Now here in this equation, the electric field intensity is inversely proportional to the cube of the distance. For the dipole concept, the electric potential is inversely proportional to the square of the distance and electric field intensity is inversely proportional to the cube of the distance.